Hi, I'm Mitchell Cairns.
And I'm Parker Milkosky.
And today, you're going to be watching Sedimentation in Johnson's Pit. We hope you enjoy it. Sedimentation can be found everywhere, in the mountains, the streams, the rivers, and here, in Johnson's Pit. As you can see from the view of Johnson's Pit, there are many types of sediments that can be found in this area. In fact, in this sample size that is picked up, I could see several different types of sediment. And all these sediments can all be classified if you have right tools for measurement. There are three ways of classifying a sediment. You can classify them by their porosity, you can classify them by their length, and you can classify them by their makeup and shape. Today, we will be examining these three different measures of measuring them. One way to measure sedimentation is to measure porosity. The porosity is the ratio of volume openings, which are called voids, to the total volume material. The way that we are going to experiment with porosity today is we're going to take water and pour it into different types of sediment. If it takes a longer time to absorb, then it has lesser sediment because it's much finer and there's much less opening. If it takes very little time to absorb, then it means it has greater porosity, for it means there's greater openings. Imagine rocks put together. There are more openings than if you have tightly packed dirt. So let's find an area to measure. Right here, here's a very good area. It's very flat, so you won't have to deal with runoff as much. And it seems to be a wide variety of different things. So we're going to take this water and we're going to pour it directly into the dirt. And if it takes a longer time, and it has lots of porosity. Okay, as you can see, there is still water on top of this sediment. This sediment is obviously very fine and has lesser porosity because, as you can see, I can still get my fingers wet in the sediment. Therefore, this is a lesser porosity.
Here we have another type of sediment, a pile of rocks. We can already tell that this isn't going to be very porous once we try and pour the water on it. Let's just show you anyway. As you can see, it already traveling down. There's no sustainable water there left. The rocks, it's already gone through the rocks. It's very porous.
As you can see, Parker is now going to do a demonstration of the porosity.
Got it. Alright.
3, 2, 1, pour. Keep pouring a little bit more. Okay, that seems good. Okay, it seems to have been absorbed a decent amount. You can still see a little bit of dampness, but the majority of the water has been absorbed. Another interesting fact is the fact that there's runoff. This is on a hill, and because it's absorbed, it started to run down because there was nowhere else to go.
Another way of determining the type of sediment is to measure it in centimeters using the Wentworth scale. What you do is take the average length of a piece of sediment and then you compare it to the chart. And that chart will tell you what type of sediment you have. If it's fine, grainy, any of that stuff. So we can go look at the chart.
So today we are going to measure the different types of sediment that can be found on the ground. And we're going to take these measurements in a journal, which Parker has by his side right now as he films. And when we get back to his laboratory, aka Parker's house, we are going to determine the type. So let's find a good type of sediment to measure. Over here, this one is very large, but not too large. Okay, according to the scale, we have to measure this in centimeters, because this is the standard unit used around the world, except for in America. Upon measuring, we get a measurement of around 6 centimeters, maybe 6.2. When we get back to the laboratory, we will compare this to a chart and we will determine what type it is.
Right now, I'm looking for a small sediment to show you. This one. This one measures about 6.6 centimeters in length.
When it measured on the diameter side of the ruler, of course, it only measured to about 1 centimeter, maybe 1.2 centimeters. Okay, Parker, as you can see over here, we have another type of sediment that's very interesting. It is very red, and it seems to have been brought up from tire tracks, possibly somebody using an off-road vehicle to ride out here.
ATV. All-terrain vehicle. You know what I think it is? I think it's clay.
Well, we're going to determine this later. However, the first trick is you have to find one little granule of it.
Doesn't clay have minus on the inside and plus on the outside, if you know what I mean? Like,
It does, if you can,
it attracts nutrients.
as you'll see later, if I can find one granule size, it's very difficult due to the fact that there are so many. Okay, I now have one on my finger, and I can see that it measures at less than about 1/8 of a centimeter. So a 1/8 of a centimeter is 1/8, of course, would be estimating around 1 divided by 8 equals. We're going to go over the math later.
Yep. Just write that down.
Of course, we're going to go talk about that later.
Yes.
One way to distinguish these types of sediment is by the composition. The three main kinds of composition that can be found in the sediment are clay, silt, and sand. By mixing different amounts of these different substances, you can form many different types of sediments. For example, you can make silty clay, you can make loamy sand, and silty loam. A loam is a mixture that is almost 33% to make a very easy one.
Yeah, that's pretty accurate.
There's some interesting information about clay. Clay itself is actually a negatively charged substance. However, the nutrients in it, such as calcium, magnesium, potassium, and all the nitrates, they're all positively charged. One can hardly talk about sediments without talking about the life that is in the sediment. As you can see right here, we have a macroorganism. It seems to be some type of ant, but we cannot catch it due to the fact that it is very seedy. We're going to remember this later as we try and identify this. Of course, we also have plants growing out of this sediment. Again, we cannot identify these, but we will try to later based off the footage we have of them and a very good plant guide that we will find online. The internet is very useful for this kind of thing.
Oh, and did we ever mention how important the sediment type is for plants? I mean, it just is so important. It's incredible. You couldn't have any of this stuff growing here if it was just regular dirt or if it was mud. Any of that stuff. It was just rocks, period.
I'm sure if we dig down, we are going to find many more types of life. Organisms tend to be found very deep in the ground, where they dig burrows for them to live. However, we are not seeming to find anything right now. However, there's probably something in this area that we're looking. As we like to leave the environment as it was found. This is because we do not want to change things. Human change is very bad.
Very bad, indeed. very much like mud.
Litter can very often be found in sediment. This is because humans often leave behind things that they do not wish to carry along with them longer, as a type of ease, you know? So right here we have some kind of ribbon that people just left lying in sediment. This is very bad for the environment and should not be done. We're going to put this in our trash bucket as we continue on our walk.
Same trash bucket, bro, but you can take it. Put it in there.
Okay, as we come along out here, just outside Johnson's Pit, you can also discover the many types of man-made sediments. As you can see on the ground, we are walking on a type of gravel or cement. Man makes these types of sediments to make it travel easier over the many millenniums that man has existed. This is because man has not developed as easily to walk through dirt and rock. These make it allow it to be much flatter, and it also allows it to be much sturdier, which is very important when you're trying to walk. Later today, we determined the length of several different types of sediments in the hopes of later figuring out what they are. The unmarked scale uses millimeters, and it gives the average, and it gives the length of different types of sediments and how you can define them. We have 5 different lengths, and we are now determining them. Because the scale is in millimeters, we will convert the centimeters into millimeters. The first one was 6 centimeters. This can be converted into 60 milliliters, and 60 milliliters is considered a pebble, which is a type of gravel. The next one was 0.6 centimeters. 0.6 centimeters is 6 millimeters, and 6 millimeters again can be defined as a pebble, which is a type of gravel. The third one we measured was 1.2 centimeters. 1.2 centimeters is 12 milliliters, which again be considered a pebble, which is a type of gravel. The fourth one we measured had a measurement of 1/4 of 1/8 of a centimeter. When we do the math, that is 0.03125 centimeters. When converted to millimeters, this is 0.3125 milliliters. This can be considered a medium sand. The fifth one that we measured had a measurement of 18 centimeters. 18 centimeters is 180 milliliters, and 180 milliliters is a cobble, which is a type of gravel again. Today, we talked to you about the many wonders of sediments.
For example, we talked about the many ways to identify sediments, including porosity
and length using the unmarked scale
and composition.
We also use experiments to go along with these different ways of identifying them.
We talked about life in sediments, sediments in water, litter in sediments,
and finally, we talked about areas that man created that have sediment in them to make ease of travel.
We really hope you learned a lot from this documentary.
And we hope you enjoyed it. Thank you for watching.